When my visit to Bulgaria was planned, I requested to present a lecture on the former Soviet Union space program. This is really important in terms of some historical highlights, and because I've been for years a part of the Soviet space program in terms of planning and implementation of many missions, it's a great challenge to me, and I was really pleased just to accept such an invitation. But contemplating about this lecture, I thought that historical highlights are certainly very important. They should be instrumental for the current activity, for projecting the future. So I a little bit changed the original title of the lecture. So this is Soviet Russia Space History, Current and Future Activity. And this is important in order you would not leave this audience having a wrong idea that space activity terminated in Russia. This is absolutely not the case. We have still quite good missions and also quite reasonable and very challenging planning for the future. What I'm going to tell you today, this is a short outline. This is historical facilities, launcher, Vostok being lifted before to be launched. So, this is very briefly just what I'm going to tell. It was such moon race, and it's unfortunately we didn't succeed, and Americans won with their Apollo program, and I believe, personally, I believe that our disadvantage in this program mostly was caused by the very premature death of Sergei Korolev, which happened in 1966 in January. Well, you know, both, let me just to make very short remark, both Korolev and Keldysh was so much enthusiastically dedicated to space program, and among others, they contributed a lot, and they didn't save their health. So they passed away being quite young by the just general standards. So, and it was great loss for the Soviet space program indeed. And of 60s is also manifested by our first success towards the Venus. And the great accomplishment, great achievement was Venera 4, which descended, parachuted in the Venus atmosphere. Let me remind you that until that time, the parameters of the Venus atmosphere was very poorly known. And we just even addressed the Venus like being a twin of our Earth. And it was assumed that the planet possessing very favorable, very clement climate conditions. But it turned out that it's absolutely hell, that it's just at the world, absolutely unlike our Earth. And it's composed of mostly CO2, no oxygen, just to breathe, you know, and especially very high temperature. Turned out it was 550 degrees centigrade, you could imagine. It's a melting temperature for some metal. And the pressure as high as about 100 atmosphere. This is just pressure which we have in our ocean at the depth of 1 kilometer. So you could imagine which conditions exist on the Venus surface. But the first Venera 4 and followed it, Venera 5 and 6 mission. We had very poorly idea about the model of such an atmosphere, so the vehicle were designed on some kind of the ad hoc finding, a sort of, which we could assume exists really on this planet. So their final pressure, which designed just in this capsule, was about only 15-18 atmosphere, and it was final pressure under which the capsule was crashed, collapsed completely, and it was only altitude 24 kilometers. So we extrapolated it up to the surface, and just the parameter which I told you about were found due to such extrapolation. Well, that's also time when we undertaken our new design mission to Mars, but unfortunately they were unsuccessful because they were designed quite heavy, designed to be launched by Proton launcher, modified Proton launcher, but both Protons, it was 2 mission plans at that time in 1969, both Proton mission exploded just on the launch pad. So no one mission started at that time. It was very tension period of moon race between US and Soviet Union. And well, after Korolev death, we felt, and we were convinced even, that we'll lose just competition with America for the landing man on the moon surface. And we need to, to do something which, if not being equivalent of the man landing, but it could be extremely beneficial in terms of science. And Babakin, general designer, suggested very clever ideas. Ideas to launch on the moon with the new available facilities, Proton launcher, just vehicles of robotic type, in order just to reach, to succeed in very important goal, to return automatically lunar samples from moon surface to the Earth. So without any assistance from human, I mean operating in the spacecraft, and also to launch automatically operating rover on the surface. And so this was the idea which underlied the design of several lunar vehicles of new generation. The first success came with the launch of Luna 16, which really descended, landed on the moon surface and took the sample with the manipulator, put it in the special container, and this container will return back to the Earth automatically, automatically launched from the moon surface. And this is the design of this mission shown here, and this is some utilization of this vehicle in order to reach the goal. And this also 2 lunopods, so-called moon rovers, which was, well, by the way, this is the container capsule returned back by the Luna 16, and it was followed by the several other missions, and we took samples of the lunar soil from 3 different sites on the moon surface. Very important for science. And this lunokhod, LOVA, this is lunokhod 1, which traveled over the moon surface for more than a year and collected very important data. And at the first time, for example, it was deployed so-called laser reflectors in order to measure distance between Earth and the moon. And at that time, it was absolutely incredible accuracy, better than 1 meter. Could you imagine? And this should be compared to the average distance between Earth and moon, and the moon 380,000 kilometers. So you should compare it in terms of the accuracy only within 1 meter. Right now it's even much better within 1 millimeter. So just to let you the principal ideas about that. So this is some kind of the panoramas. This is the platform from which lunokhod just slipped down to the surface, and this is its platform configuration, and this is some close-up view of the lunar surface. So this is the configuration of the Luna 16 vehicle, and this is the manipulator which was used in order to take samples from the surface, and this just is the capsule container which used this one in order just to return back the soil. And this is just the soil which was delivered to our Vernadsky Institute for the in-depth study. Well, as I said, I've been personally very deeply involved in this mission and the whole lunar program, planetary program, and this is the press conference briefing after successful flight of Luna 16. Well, that's me. Very young at that time, but it was, let me address that time like high days in my personal career. And this is chamber where Luna 16 sample was placed under inert gas, in order to preserve it, not modified by the Earth's atmosphere. And well, we just look how, at the first time, how the lunar soil looks like. So excited, And this is the Babakin, chief designer. This is the main, very high-level administrators at that time of the ministers, which were equivalent to the current Roscosmos, okay? And again, this is young Mikhail Marov, just standing and exciting, looking at the soil. Okay, well, it was followed by the several lunar missions, in particular very capable orbiters, and this is the examples of images were returned by such orbiters. And it was extremely important success in the study of Mars, Venus and Mars. Venera 7 was the first lander which was just soft landed on the Venus surface. It was in the 70s, and it was followed by Venera 8 in 72. And this is the modified, straightened up capsule lander which survived under so hostile conditions on the Venus surface. And also it was launched toward Mars, and the first success of landing came in 1971. Mars 3 lander became, it's shown here, became the first in the history, the first spacecraft, first lander, which successfully reached the surface. And again, with the petals, very cleverly designed, which operated just to be operated on the surface. Unfortunately, after successful descending and landing with a very, very robust engineering and very accurately designed the whole sequence of operations to land on the surface, unfortunately, after deployment, the spacecraft, the vehicle, lander, operated on the surface only within several tenths of seconds. But it was happened by our design because at that time the severe dust storm just happened to Mars, and it certainly influenced just operational program and destroyed the spacecraft after its landing and possibly during this landing even. And this success was followed, in terms of landing, it was followed by the several missions. It was just, unfortunately, it turned out doomed Mars fleet because we used not very good manufactured electronics at that time, and so influence on the badly impacted on the operation of these 4 vehicles, and among them only Mars 6 just operated more or less properly and became the second lander, but it was, I didn't say soft landing, but at the first time in the history measured accurately parameters of the Mars atmosphere, direct in situ measurements, and with also quite successful Mars 4 and 5, which returned back the first images of the Mars surface back to the Earth. I need to confess that it was not completely high quality images, but still they were very important to us for that time. And this is the example of black and white and even color images of the Mars surface. It's incomparable with the quality which returned by the current missions to Mars operating even right now. But still, possibly in the middle of 70s, it was very interesting, very challenging idea to launch the balloon in the dense Venus atmosphere. And this project was jointly studied by Soviet engineers and French colleagues. This balloon intended to float in the Venus atmosphere, just in the visible clouds above the surface at something like 50 kilometers, and to operate for about at least 3-4 weeks. And it could be drifted by the super rotation of the Venus atmosphere, which was found by the previous mission. Super rotation, it means that at this level, 50 kilometers, winds blow at the velocity of something like 100 meters per second. So the balloon could cycle the planet for about 4 days. Well, but this project was quite well advanced, and this is the balloon itself, the testing in the Toulouse, France, in the testing facilities. And this is the main designer from the French side. This is the designer from Lavochkin Enterprise, okay? And this is me. We're just discussing just the progress and with this balloon design and testing. Well, instead of the balloon, which was intended to be launched in '83, it was the idea completely modified, and instead of the balloon launch, we undertake Vega mission in order just to take advantage of the Halley comet appearance approaching the sun in this year, and such event happens once in 76 years, so this event couldn't be missed.